Hi everybody, and welcome to our unit on acids and bases. Our notes for today are rather short and they are a review from first semester. We are going to talk about, or just review, naming acids and bases. All right, so first up, as far as dealing with an acid and how you know you're dealing with an acid. Acids always begin with hydrogen. So any compound that you see that begins with hydrogen and is not water, you can consider an acid. All right, all acids are grouped into two general categories, and that is based on how many elements are in that particular acid. You have binary acids, and binary, so you have just two elements are going to be in there. Obviously, hydrogen is going to be our first one, and then we're going to have a negative ion is going to be that X. That is going to be a negative, all right, ion. Okay, so as far as naming a binary acid, okay, the prefix is always hydro. Then it's the root of whatever that negative ion is, and then it's going to end in ic and then the word acid. So for example, HCl, all right, so I see that there's a hydrogen there, so it is an acid. There's only two, so it is hydro, all right. Then the root is chlor, because chlorine, and then ic, acid. There's one hydrogen. Hydrogen, remember, in acids has a charge of +1. So we're dealing with a positive ion there. It's +1. Chloride is -1 because it is in group 17. You're definitely going to need your periodic tables. And group 17 is -1. So you will just have HCl. Right. So a couple other examples just to go through. If we had, let's say, HBr, all right, that is going to be hydrobromic acid. Okay. If we were to have H2S, all right, so I still, even though there's two hydrogens here, I only have two types of elements. So this is still binary. So it's going to start with hydro. And then this is hydro. We might think it would be hydrosulfic. It's actually, for whatever reason with sulfur, we do not truncate it. So we do call this hydrosulfuric acid. All right. Again, as you're learning, if you were to have written hydrosulfic, it's okay. Sulfur is just one that we don't actually truncate. All right. So that is the situation for your binary acids. All right. Again, you know it's binary if you're looking at the name because of this hydro. Hydro is only used for binary acids. The next grouping, or our second grouping for acids, are known as ternary acids. Sometimes these are called oxyacids because they're going to have oxygens in them. But all ternary acids contain polyatomic ions. So please remember, again, with your periodic tables, you have this polyatomic ion chart on the back. You're going to need this, all right? You had this from first semester. You definitely are going to need that polyatomic ion sheet. Because ternary acids, the name is actually based on the polyatomic ion. If the polyatomic ion ends in ATE, if it ends in 8, the acid is going to end in ic. All right, so let's see what's going on. So if I were to give you H2SO4, you're going to see this and you're going to say to yourself, all right, it's an acid because it starts with hydrogen. It's a ternary because it has more than two elements in it. I'm going to check to see what SO4 is. Now, we should know this by now, but SO4 is sulfate ending in ATE. So I'm going to change that 8 to ic, and it becomes, again, we don't truncate, so it's a little weird, sulfuric acid. If you were to have written sulfic, that's okay at this point. As you move on, you'll kind of realize how that goes. Let's look at another example, HNO3. All right, HNO3, we're dealing with the polyatomic ion nitrate. All right, so we're going to go ahead and change that 8 to ic, and this just becomes nitric acid. Please note, there's no hydro with these. All right, we only use hydro for binary acids, so please don't fall in love with that hydro. All right, let me give you another example to work with. Let's try phosphoric acid. All right, so I see that it ends in ic, which means it came from 8. So that means this is phosphate. I'm going to check my polyatomic ion sheet. Phosphate is PO4 3-. So my formula for this, phosphate is 3-, hydrogens +1. I need 3 hydrogens to go with my phosphate. So that is the formula for phosphoric acid. All right. Now, if your polyatomic ion ends in ite, I-T-E, the acid will end in us, O-U-S. So for example, H2SO3. SO3, as we can see on our polyatomic ion sheet, and I don't know if you can see this very well, but it is sulfite. So this turns into sulfurous acid. All right, so if we take a look at another one, let's kind of stick with that same theme, and I were to give you HNO2. NO2 is nitrite, so this one is going to be nitrous acid. All right, only 1 hydrogen in nitrous acid because NO2 has a -1 charge. So we are going to be doing kind of going back to those ionic compounds, making sure those charges balance, because that is the same with the acids. Okay, so the last thing we want to talk about today is something a little new to us, and it's something we're going to be using a lot in this unit. And this is the idea of a strong or a weak acid or base. When we say we're dealing with a strong acid, it means that it completely ionizes in water. And we're going to talk more specifically about that in future notes. All right. Weak acids are only going to ionize slightly. All right. So you don't get that complete ionization. For today, what I want you to focus on is remembering what are our strong acids and strong bases. So our strong acids, all right, and this is just something you have to kind of remember. For binary, there's only 3 strong acids that are binary: hydrochloric, hydrobromic, and hydroiodic acid. All right, those are strong. If you get any other binary acid, it is considered weak. All right, for your ternary acids, if the difference between hydrogens and oxygens is 2 or more, it is a strong acid. So what do I mean by that? All right, so let's look at some examples. If you're dealing with H2SO4, all right, so what you're going to do is you're going to actually say, I have 4 oxygens, I have 2 hydrogens, 4 minus 2 is 2. So that means it is 2 or greater, so this one is strong. All right, if I'm looking, let's say, at H2SO3, 3 minus 2 is just 1. So this would be a weak acid. It's as simple as that. That is all you have to do for those ternaries, is just look at the difference between the oxygens and the hydrogens. And if it is 2 or greater, we consider it strong. If it is not 2 or greater, if it's something like this, if it's just 1, then it is going to be weak. All right. And actually, while it doesn't seem like case, you're going to have a lot more weak acids than strong ones. Okay. So let's take a minute and talk about bases. All right. As far as bases go, your strong bases are all going to be hydroxides. So they're all going to have hydroxide. Remember, hydroxide is OH minus. Of group 1 and some from group 2. So what do I mean by that? Well, something like sodium hydroxide, NaOH. Sodium's +1, hydroxide's -1. This is what I mean by a hydroxide of group 1. It's a hydroxide with a group 1 from our periodic table, all right, with a group 1 element. So this would be considered strong. Okay, calcium hydroxide is also strong. So remember, calcium's +2, it's in group 2. So for this case, you need 2 hydroxides. That's why we're taking some time to practice these today, just to make sure, to remind us about our naming and formula writing. Okay, if you are hydroxide that is not from group 1, or is not calcium, strontium, or barium, it is considered a weak base. Okay, so you're going to have some practice with this, and we are going to be using this all throughout this unit. All right, have a great day.